Hey everybody, Mr. Lake here. I realized that my previous Math Bootcamp Significant Figures videos, I don't know why I'm wearing headphones. I don't need to wear headphones. I realized that my previous Significant Figures videos did not do a good job of explaining what to do about placeholder zeros, and that has caused some confusion, or at least failed to uh, divert some confusion that could have been diverted. So I want to talk a little bit about placeholder zeros in this video. Nothing new, but hopefully some clarification that a lot of people need. Okay, so here are the two things that I want to talk about. Really, I'm just going to go over a bunch of examples, but here are the two things to think about. Number one, sometimes numbers have zeros that are not significant figures, but that doesn't mean that they're not important. It is possible for a zero to be important and something that you have to keep, even if it's not a significant figure. More specifically, sometimes zeros act as placeholders. They keep things in their place. For example, in the number 0.015, these are placeholder zeros right here. They're not significant, but you can't just say, oh, well, then that means that they're basically not there. All right. There's a very big difference between significant or being not significant and being not there. If they weren't there, the number would be 15. The number is not 15. The number is 0.015. Those zeros are really important to be there, right? Because they keep the one in the hundreds place and the 5 in the thousands place. In other words, they are placeholder zeros. They keep the other significant figures in their places. Similarly, if the number were 1,500, right? The 1 and the 5 are significant figures. The zeros are not significant figures, but they're important. Just because they're not significant, you can't say, oh, well, this number is basically 15. 1,500 is not basically 15. Those zeros are really important because they keep everything in its place. They keep the 5 in the hundreds and the 1 in the thousands place. All right. So, another thing that this means is that when you round numbers, you may need to replace digits with placeholder zeros. And this right here is the number one thing that people get wrong on tests, that people uh, forget when they're doing math. This is the number one rule that messes people up, or the number one thing that messes people up. So we are going to talk about all of that, and we're going to talk about it right now. Let's do some examples here. I'll come back. We're going to round all of these to three significant figures. It doesn't matter why we're rounding to three significant figures. Maybe each of these is a, answer to a calculation and we get to keep three significant figures, but we're just going to round each to three significant figures. And what this is going to do is it's going to show you placeholder zeros, both leading placeholder zeros and trailing placeholder zeros, and why they're significant, and bad choice of words, why they are important to consider even when they're not significant. Let's take this first example. We're rounding to three sig figs. Here's our first sig fig, right? The three zeros at the beginning are not significant. First sig fig, second sig fig, third sig fig. This is where we're going to stop at the 8. We have to look at the next number, though. It's a 2, so the 8's not going to round up. Now, what I'm seeing some people write on their quizzes and stuff is, oh, okay, well, this number is 548, because those are the three sig figs. Remember that rounding, when you round something, you shouldn't be changing the number. You're slightly altering the accuracy of the number, but you're not changing the number. So does it make sense to say, oh, this number here is 548? No, this is 0.005482. Completely like in a different realm, right, than 548. So these three placeholder zeros at the beginning, you have to keep those. Those have to stay there. because they keep these things in their places. This number still only has 3 sig figs, but all of those sig figs are in the right place. That's the function of placeholder zeros. These are leading placeholder zeros. Now let's do, this is one that a lot of people get wrong, when you have to introduce your own placeholder zeros. So let's talk about this number. We're rounding the 3 sig figs. The first sig fig is the 3, the second is the 8, the third is the 7. We're going to look at the next significant figure. Hey, it's a 9, so that means the 7 is going to round up to an 8. So we're going to get 3, 8, 8 are our 3 significant figures. Now, I see a lot of people every year, a lot of people just stop there and they say, oh, okay, the number is 388 because those are the sig figs. How did we round 38,792 to 388? There's something wrong there. What's wrong is that these are our 3 sig figs, but the 3 needs to be in the 10,000s place. The 8 needs to be in the thousands place, and the 7, which is now an 8, needs to be in the hundreds place. So we have to add 2 placeholder zeros to the end of the number to keep those things in the right place. Now this makes a little bit more sense, right? We just rounded 38,792 to 38,800. That sounds like something that you could do, right? I am going to stop talking for about 5 seconds so that you can pause this video and do these other examples on your own. So please pause the video, do these other examples, and then I will walk you through them after a short break. All right, I hope everybody paused the video and took a moment to solve all of these. Let's go through them together. Still, we are rounding each of these to 3 sig figs. So in this number, these are our first 3 significant figures, right? All of these leading zeros are non-significant. So what are we going to do with that? We're going to look at the next number. It is less than a 5, so the 9 is not going to round up. But our number is not just 209. We have to keep these significant figures, or sorry, these leading zeros so that the significant figures are in the right spots. So this number is 0.0000209. Now what about this number? First sig fig, second sig fig, third sig fig. That's interesting. This 0 is followed by a 9, so it's going to round up to a 1, and we get that our 3 significant figures are 2, 0, 1, but they need to be in the tens, thousands, 1,000, and 10,000, 1,000, and hundreds place, respectively, so we've got to add a couple of placeholder zeros to keep them there. Next one. Our first 3 significant figures are 1, 0, and 9. But this is actually more of a kind of interesting rounding situation because the 9 is going to round up to a 10, which is going to then round this up. And so we get that 0 goes up to a 1, but we still need a third significant figure. So we have to have a significant 0 at the end here. Okay, let's do this one. The longest number on the list, I think, or at least the biggest number on the list, but maybe one of the easiest. 249, those are our first 3 significant figures and what we get to keep. We've got to look at the next one afterwards. The 9 is going to round up. So the 7 rounds the 9 up to a 10, and we get 2, 5, 0 plus 1, 2, 3, 4, 5 placeholder zeros. Now, this is interesting. This is really interesting because we did this right, but this number only has 2 significant figures. Technically, this 0 is significant, But we don't have a way of showing that. Now, there's two ways that we can write this number so that we can show that it's significant. One way that some people write numbers to show that a zero in a line of zeros is significant is they will put a line above it and say that is significant. That's all right. The best way to write this number with that zero being significant would be to write it in scientific notation. So if we did 2.50 times 10 to the 1, 2, 3, 4, 5, 6, 7, seventh power, this shows that the number has three significant figures. That zero is significant. All right. So we got a little bit into the weeds on this one, but that was a really good example, actually, because it shows us a little bit about how sometimes scientific notation is our tool of rescue, the thing that's going to allow us to show what we want to show. Next example. These are our three significant figures. The last one is followed by a 7, so the last significant figure is going to round up. We get 0.00346. Remember, those leading zeros are essential. Even though they are not significant, they are necessary. Now, this is an interesting number. Here's our first three significant figures. The last one is followed by a 1, so it's not going to round. We get 139 are our significant figures, and then we need to put a 0, a placeholder 0 there to replace the 1 so that the 1 here stays in the thousands place and the 3 in the hundreds and the 9 in the tens place. And then what do we do with all of these decimals? Well, we only get to keep three significant figures. So that's it. That's our number. These all got dropped because they are additional figures that we can't keep. There's a strange, almost symmetrical number here. These three ones are going to be our first three significant figures. And the number is very simply 0.000111. There you have it. Now, here's another good example, kind of like this one up here. These zeros in the middle here are sandwich zeros, so they are significant, which means that our first three sig figs are this one and both of these zeros. And the last zero is followed by something less than a 5, so it's not going to round up. So writing this number with three significant figures is this. But obviously that only has one significant figure. So how do we indicate that these two zeros are significant? Well, again, what some people will do is draw a line above the last significant zero in a line of zeros like this. And so that shows that these are all three significant figures. But really the best way to do this would be to write it 1.00 times 10 to the 1, 2, 3, 4, 5, 6, sixth power. That would be the best way to write that number. So I hope that this helps to answer some people's questions. I hope it helps to clear up some confusion that I know that a number of you have been having about how to round, how to deal with significant figures, and especially what to do with those pesky zeros, especially when they're not significant, but you still need to keep them because they are placeholder zeros. So the best way to really just, get this in your brain is to do lots of practice. Hopefully this little bit of practice helped, but we've also got those couple of worksheets that you can work on to practice as well. As always, if you have any questions, please let me know. I'm more than happy to talk to any of you and help you with anything. I will see you next time, and until then, take care of yourselves. Bye, everybody.